Hey, welcome back to Fat Mama Physics. In this video, we are going to continue on with 5.2 linear relationships. I have a second example, which I want to show you because it is slightly different from the first one. The first example was you started 1 meter away from the house. Over time, every second you moved 3 meters away from your house again and again and again as you walk to school. This one, we will start off the example with borrowing or renting DVDs, which is probably way out of your time, but maybe not. So let's take a look at this example here. We're going to do exactly the same thing. We got a table. We're going to make some coordinates, graph it. So take a look at this over here. Notice that on the right-hand side, we have the number of DVDs rented. So it's kind of like, I guess would be for you, would be renting videos online, I guess through YouTube or something. But you actually go to a store and you pick up the DVD and you pay at the counter. You have to return after so many days. It was back in the old days. Okay, so if you rent 1 DVD, you would have to pay $4.50. After you rent 2, you pay $9. Well, of course, every DVD is $4.50. So every DVD that you rent is going to be $4.50 more than the previous, and then your previous cost. So that's kind of the that also reinforces the idea of independent and dependency. Your independent variable is kind of like your DVDs. The more DVDs that you rent, the more you have to pay. Well, duh, right? So, but on the graph, that's exactly what you would show. So we talked about how your independent variable goes on your x-axis, your dependent variable goes on your y-axis. If I had to graph this later on, I'm just going to put a note there that my x is going to be my DVDs rented, y is going to be my cost. So notice the table is not completely filled up. So let's fill these out together. And so that means we have to figure out the pattern here, which every time we increase the cost by $4.50, which is the cost of 1 more DVD. So here, $9 plus $4.50, that's going to be $13.50. And notice that my table tells me my units, which is great. I don't have to write it down again. 18 plus $4.50 is going to be $22.50. Now, the other thing I want to note is that notice I put down the 0 there, even though it doesn't have any significance. It doesn't seem to have significance, but because we're talking about money values, we always should show the 2 digits that are after the decimal. So now we want to describe the pattern between the number of DVDs rented and the cost. So here, after you increase the DVDs by 1, plus 1 DVD, you are going to increase your cost by $4.50. Okay, so now we know the relationship between increasing the amount of DVDs and how much you have to pay for that. I'm actually going to get us to try this one. You're going to try to write an equation for this relation. So I want you to use D, the variable D, for the number of DVDs, and I want you to use the C, the symbol for the cost for the variable describing the cost in your relationship. Okay, so write the equation for this relationship. Good time to pause the video and do so. Okay, so I'm going to talk through it and show you why it is the way it is. First of all, our cost is going to depend on the number of DVDs rented. If I rent 1 DVD, I'm going to pay $4.50. If I rent 2 DVDs, that's going to be 2 times $4.50. So notice the 1 and the 2 and the 3 times that I'm multiplying by the cost of 1 DVD. That is represented by D, the number of DVDs that I rent. And that's going to be multiplied by the cost. Because if I rent 1 DVD, that's 1 times $4.50. If I have 2 DVDs, that's 2 times $4.50, 3 times $4.50, etc. And that's going to give me my total cost. We can even try this. If we rent 0 DVDs, we should not have to pay anything. If I put 0 for D, 0 times anything is 0. My cost is 0. That checks out. If D is 1, 1 times 450 is 450, 2, etc. So it looks like it's going to work out. If I had to write using X and Y, it probably would look like this, but that's kind of up to you. X for the X-axis, Y for the Y-axis. Okay, the next step is to write all the values up here in terms of coordinate pairs, the coordinates, so then we can graph this later on. So maybe this might be another chance for you to pause the video. I'm going to do the first one for you. So X, the first row is X equal to 1, which is my DVDs rented. Y here is 450. Why don't you do the rest for the rest of the coordinate pairs? Good time to pause the video. Okay, so I will just quickly jot these down. Okay, so here are our coordinate pairs. Right now we want to graph the table. We want to draw the graph. So before we even put in the intervals, before we plot anything, there should be 3 things that you're doing. You have to set up your graph. So I'm going to give you a chance to think about it, draw your own graph, or think about what are the 3 things that you should be putting on there. Good time to pause the video. So if you thought you need a title, you need the X-axis labeled, you also need the Y-axis labeled, then you are correct. If you actually thought about what they could be, bonus points for you. So this table, this title, I could name it the cost after renting D number of DVDs. And then for my X-axis, that's going to be number of DVDs. I could put a variable there if I want to. And then for my Y, it would be the total cost measured in dollars. So that, I forgot to underline my title. Now I'm going to label my axes. So if maybe it would be a good chance for you to think about how you would label the axes given our coordinates. So X's go all the way from 1 to 5. Our Y's go anywhere from 0, 4.5 to 22.5. So based off of what you see, the gradients on the grids on this graph, how would you divvy up the X and Y axes? Good time to count and think about it, and to pause the video. So it looks like my 1 to 5 is the same situation as before. Assuming this is the same graph as the previous, then if it goes up to 14, the maximum amount of space I could use here would be up to the 10, meaning 10 divided by 5 is 2 boxes per increase in the X. Okay, so there's my X. Now for the Y, I believe I still have 16. I double checked that it should be 16. Then I need to find a way to divide 16 among 22.50, which is, it might be it's definitely, I can't do 1:1 ratio. That is too, that's not going to give me enough boxes. So what if I did 1 box is equal to $2 instead? So if I did 1 box is 2, 16 times 2, that's going to give me 32 is going to be my cap. That kind of works. I could also do 1.5 in which 16, so every box is $1.50, and that's going to give me what? That's going to give me $24, which, I mean, 32 would work. It'd probably make my graphing life a little bit easier, but for the purpose of using as much graph paper space as possible, I'm going to use 1 box is $1.5. So let's label the graph. Okay, so this is my graph labeled 1.5 increase, so goes up all the way to 24, which encapsulates the 22.5, which means my entire graph will be within my graph space. Okay, so now we do the graphing bit. Okay, so we work on the first data point, which is 1 along my x-axis, and then I rise up 450. So 450 is right here. Notice I'm not counting the boxes. I'm making sure I'm reading my axes for my value here. So there's my dot. Next up is 2 DVDs at $9. Hey, notice the 1.5 worked really well. Okay, and then 3 goes up to 13.5. So 13.5 is right there. 4 goes up all the way to 18. And then 5 goes up to 22.50. Okay, so those are my dots. Maybe I put them in different colors so we can see. Oh, that didn't really help. Okay, you get the idea. So here's the next question. can't, like my previous example with the distance and the time, can we draw a line through all my dots to show the relationship? If you say no, you are correct. Why are you correct? Because if I drew a line through all these dots, then I'm saying that it's possible to rent 1.5 of a DVD. If I rent 1.5 of DVD, that's going to cost me, I don't know, something along $7 or something. Which, you can't really do that. You can't go to the store and say, oh, can you cut this DVD in half for me so I can maybe watch half the movie? It doesn't work that way. So from a physical and meaningful standpoint, there is no way to say that that you can draw a line through it to show a continuous relationship. What we say instead is that these data points are discrete. And why are these data points discrete? We just told you we can't rent half a DVD. So what that means is all the points between 1 to 2 don't exist. They don't make sense. They don't exist. So maybe another way to phrase it, the points between, the values between the data points don't make sense, or the values between the data points don't exist. However, we do see that the lines lie along a straight line, so we do say that this relationship is linear. And how does it make it linear? Well, every time we increase the DVD count by 1, as D increases by 1, the cost increases by $4.50. I just used a little symbol there just to show us what that is. But it's a constant increase. It's not like the next DVD I rent is going to be more expensive because I rented the first one. Sometimes it works that way, but not in this case. And that's a constant change. A constant change means linear relationship. So, you did a great job with this graph. Thank you for being patient with me. I think it took way longer to explain some of these concepts than I normally do. But graphs are tricky, so take your time. Get into practice, you'll get better. You'll definitely need this in science, and I can tell you that getting the higher levels in science in terms of designing your lab means drawing good graphs, showing your relationships, and analyzing everything you can from these graphs that you get, okay? So, thank you for watching. I wish you good luck. Fat Mama Physics signing out.